My name is Bruce Knight. I established a company in the UK called Legume Technology nearly 25 years ago. It's based on my scientific background of working with beneficial soil microbes. So what we do is we take bacteria from the family of Rhizobium, and these are bacteria that can transform gaseous nitrogen, so that's the nitrogen found in the air, and turn it into fertilizer nitrogen for the crop grower, for the farmer. This process is called biological nitrogen fixation, and it can benefit legume crops massively by taking nitrogen from the air that you breathe, that permeates into the soil, and turning it into fertilizer nitrogen. This can give you massive increases in yield. So over the last 20 years we have many field trials across Africa which can show a significant increase up to twice the yield that you would get without using the product. And this is because of the nitrogen supplied by the bacterial process. We supply a product which is based on a peat carrier. So this is a brown powder. The brown powder is sticky, and so the farmer can apply it to the seeds, and it coats the seeds, forming a coating on the seed surface. So when the farmer then plants the seed, he's actually taking with the seed millions and millions of beneficial bacteria. As soon as the plant starts to grow, when the seed germinates, the growing tip of the root is infected by the bacteria, and they form nodules, like small lumps on the root system, and these are essentially, can be considered like little nitrogen factories. They take the gas nitrogen from the air that permeates into the soil, and they break the diatomic nitrogen gas apart and make ammonium compounds. So this is essentially making an ammonium compound from the free air above the plant, instead of the farmer having to buy fertilizer products like ammonium nitrate. It's the same kind of ammonium ion that the plant gets from the bacterial process as it would from a chemical fertilizer. It's just a natural process, and it's essentially using a free resource, the nitrogen in the air above the plant. Looking at the picture, you can see these lumps on the root system. And this is where the bacteria has been invited into the plant by the plant root and set up these little fertilizer factories on the root system. So these nodules are where the nitrogen from the air, which permeates into the soil, is taken in by the plant, and this nitrogen gas turned into ammonium fertilizer for the plant. The product that we have is made to work for smallholders especially well. So we sell for large mechanized farming in Europe and North America, but in Africa we tend to find the farming size is quite much smaller than the large mechanized farms. So we have a specialism, a unique drive to try and make high quality products, but in small packet sizes so that it's available for smallholders. We sell into something like 14 African countries now. We do have a registration in Kenya, and we do sell in Kenya. We also have trials this year in Uganda and Tanzania, and also in several other African countries. So the products are available in Africa. We have a new project with funding from the Gates Foundation, and this is specifically so that we can make a more appropriate pack size for smallholders. The kind of pack size that we sell at the moment is this kind of size, and it will treat up to 60 kilos of seed. So this is quite a big packet for a smallholder to require. So the idea is that with the help from the Gates Foundation, we will be able to make small packets, which are then much more of the correct size for a smallholder to buy for a small area of land. We also have the target of producing new products which will help maize crops to establish faster and yield higher. But this is some way off from being available. But the legume inoculants are available now in several African countries. You could always look at our company website for more information. The first crop that we would look at in terms of the best benefit is soya, where we can double the yield. And certainly then any other pod-bearing crop like groundnut, phaseolus, any beans, so phaseolus beans, mung beans, even things like forage legumes, lucerne and clover, they benefit from this association as well. But I would say that the key farmers we would target first are the soya growers, but we have results in the last year on phaseolus, groundnut and soya, all showing more than 20% and sometimes up to 80% yield increase in Tanzania, Senegal and Mali. We have had trials in Kenya before, some years ago, and again showing very good results. It's a specific relationship, so if you're growing a soya plant, you will need to buy the right product to work with soya. If you're growing groundnut, peanut, you would need to buy the specific product to work with peanuts, because it's like a conversation. The plant has a chemical signal that it puts into the soil, and only the right bacteria can answer that with another chemical response, and that's what allows the infection process for the bacteria to get inside the root. Essentially, the plant invites the bacteria to colonize inside the root, because this is a symbiotic process. So both the plant and the microorganism receive benefit from the association. The plant receives nitrogen from the bacteria, but the bacteria receives sugars, carbohydrates from the plant. So they both help each other, and this is what's so elegant about this process. It's the way nitrogen is meant to move through the biosphere, and it's the way in which you can make protein from fresh air. The principle of the process is that it will increase your yield. So you might notice with a soya crop that if it doesn't have enough nitrogen, you will have yellow leaves and you will have quite a low yield. If you use an inoculant, you should have a much healthier crop without losing any nitrogen into groundwater, because the inoculant forms part of the root system. These infection sites are small nitrogen factories built into the plant, and the plant actually supplies sugars to the nodules to help them make more nitrogen. So it's a very elegant way of getting more nitrogen into the crop, and what the grower sees as a result is more peas per pod, more pods per plant, and an increase in yield, which is significant. It can take the yield from maybe 750 kilos per acre to 1.5 tons per acre. So it can effectively double the yield that the smallholder gets for a price of maybe $10, $12 per acre, something like that. So the cost-benefit ratio, the return the farmer gets, is very significant.